Hi there. In this tutorial, we will show you how to use Faust code in different contexts and how to compile it to use it for many applications. Alright, so here in this directory, I have two different .dsp codes that are Faust codes. So one is a low-cut filter and one is a noise generator. So the noise generator and the low-cut filters are pretty much the same. They're the one that you can find in the example directory from the Faust distribution. So you can find those two examples in this directory. Okay, and this is the same thing for the makefiles that I have here. These makefiles are the one that you can find in the example directory from the Faust distribution. Okay, so one is just a simple noise generator, so it just generates noise and you are able to control the amplitude of the generated signal. And the other one is an effect. So it is a stereo effect. It is taking two input signals and processing them with a low-cut filter, and it is outputting the results of this signal processing. Okay, so let's just have a quick look at these two examples. So let's open low cuts here. So here I have the declaration of the low cut filter. I won't detail it now, but there is a tutorial online on the Faust website where you can learn how to build a low cut filter using Faust. The only difference with the low-cut filter that you can find in the example directory from the Faust distribution is that here we can say that I just created a stereo effect instead of a mono effect like in the example directory from the Faust distribution. Okay, and for noise Faust.adsp, the noise generator, this example is a bit different because it is using the math.doc primitives from Faust here to write LaTeX-like function to document your Faust code, and we'll see how to use it later in this tutorial. So here is the noise generator, and here is our process, and we can see that the signal outputted by the noise generator, the amplitude of the signal is controlled by a slider. Well, actually, it is a knob, and so this signal will be outputted. Okay, so the first thing I'm gonna do now is to go in my terminal, and I can see that right now I'm in the right directory, which is the compile directory, and this is the same directory than the one I have here. You can see videos compile. So I'm in the right directory. So the first thing I'm gonna do now is just call the Faust compiler in order to create C++ code from my DSP code. So I just write Faust, which is the Faust compiler, and then the name of the .dsp file I wanna compute, and then I just validate that, and now the C++ code is written in the terminal. Okay, so we don't really want to have that because this is not very practical. We want the Faust compiler to write all this C++ code directly into a C++ file. So I'm going to specify special output, and the output of the compilation will be a file, and the name of this file will be lowcut.cpp. Okay. So now I can see that lowcut.cpp was created in the compile directory, so I'm going to open it now in Emacs. So we can see the result, and here is our C++ code. Okay. I could do exactly the same thing here with faustnoise.dsp, but we don't really have time for that now. So let's jump to the make files. So once again, you can find all these make files in the Faust distribution in the example directory. So the first thing we can do here is to write make help. So we'll have a very, very short documentation on how to use these make files. Okay. So everything is detailed here, and you can see that we have a lot of kind of applications, a lot of kind of plugins, and a lot of kind of tools that are available for compilation with this make files. So the three we're gonna use today are the make Jack Qt that makes it possible to generate a Jack application with a Qt 4 graphical user interface. We're also going to use make PureData, which compile the .cpp code as a PureData externals, and we're also going to use the make math doc that generate the example math documentation in TeX and PDF formats. Okay, so let's do it. The first one we're going to try here is Jack Qt. So basically what we're going to do here is to convert our DSP code into Jack Qt application. So a Jack application with a Qt 4 interface. So I just write make Jack Qt here. And I validate this comment, and now the compilation starts. I can see that a Jack Qt directory was created in compile, so there is nothing yet in this directory, and yeah, we have to wait a bit. Okay. All right, so I already have my low-cut filter here, my Jack application, and we shall have the noise generator very soon. Okay, great. Good. So the first one I'm gonna use here is the noise generator. So I'm gonna open it. Okay, so all right, and now I'm gonna go in my Jack Pilot connection manager panel, and I can say that I have my noise generator here. Okay, so I'm gonna connect it to Cubase 4 because I'm doing the recording of this tutorial directly in Cubase 4. So I will connect the only output of this noise generator to the input in Cubase 4. Okay, great. And I'm gonna do the same thing for playback here, and now I will start the noise generator, and as you can see, the noise generator is working with Jack. Okay, so I'm gonna close it now. I'm gonna open now the low-cut filter. Okay. So I can see low-cut here. So what I want to do is to process an input signal with this effect, and what I'm gonna do is just play a sound with iTunes here, send the signal from the sound in this effect, and then listen to the result of this processing. So I'm gonna do the right connections here. So the first thing I'm gonna do is to connect iTunes to my low-cut filter, and I will make sure that the first output of iTunes is connected to the first input of low-cut, and that the second output of iTunes is connected to the second input of low-cut. So this is the case, and the last thing I want to make sure now is that low-cut is connected to Cubase, so you'll be able to listen to the results. So here everything is fine. And yeah, one last thing I want to do here is set to disconnect this from low cut. Okay, which is my microphone. All right, okay, so let's try it and listen to the results. So I'm gonna open a sound. Actually, this is a short extract from Gounod's Faust. Okay, and I open it with iTunes. Okay, what I'm gonna do first try processing it with my filter. So as you can see, this is working. Okay, great. So you can see that my low-cut filter is working as a stereo effect here, and the result is pretty nice. Okay, so now I'm gonna close it, and I will now compile my two Faust code as PureData plugins that we're gonna use now in PureData. Okay. So here we have something special because one is a synthesizer, basically, because it is not taking any input signal, and the other one is an effect, and it is taking input signal. So I will have to use two different make option here to compile this example because one is a synthesizer once again and the other is an effect. So the first one I'm gonna compile actually is the noise generator. So I will just write down make PureData. Okay, so the two examples are compiled, of course, here because the Faust compiler is compiling all the .adsp code that are in this directory. So one thing that we can see here is that we generated PureData plugin, but we also created .pd file, which is a PureData file, and this file was created with Faust to PD, which is a tool that is integrated in the Faust distribution, and that make nice graphical user interface for PureData. So we're gonna see it in PureData now. Okay, so I start PureData. Okay. Great, and I will create a new file and I will save this file in my working directory. So I go in compile and in PureData. Okay, and so I will call it noise test. Great. Now, I will call noise.pd, all right? So in that case, I could just call noise Faust tilde, okay, and this should work. Okay. But we don't really want to use that, so we want to use here the .pd application, the .pd file that was generated with Faust to PD. So what we will write here is just Faust dsp and without Faust, noise Faust and without the tilde. And here we can see that we get a nice graphical user interface directly into PureData. Okay, so now I will create a digital to audio converter in PureData, and I will connect it to the only input to the only output I have here in my Faust generated PureData plugin. Okay, now I will make sure that in my preferences, I'm still using the jack router. Okay, so this is fine, and I will make sure in the jack router that the output signal of PD is routed to Cubase. Great. So you'll be able to listen to the result. And now I start the audio computation, and I will play. And it is working. Okay, great. Cool. Okay, so I will close this new file. Okay, yeah, I can save it. Okay, so what I'm gonna do now is to reuse the make files to compile the low-cut filter, so Faust to PD will know that this is an effect and not a synthesizer. And this is something pretty important. Okay. So what I'm gonna do first is use the touch command. So with lowcut.dsp to update the created time of this file, and then I will use make PureData effect. Okay, so compilation starting. Great, and now I should still have exactly the same thing here. So I will close PureData and start it again. Okay, and with PureData, I'm gonna create a new file, and I will save it in my working directory as we did before. So this is video, and this is compile, and here we have PureData directory, and now I will save it here. So this is a low cut, so we're gonna call it low cut test. Okay. Now, I will call my low-cut filter. So as we did before, we can just use low-cut tilde, which is directly the PureData plugin. And we can see that it has 3 inputs at the top and 2 outputs. So the first input is just the input for the parameters. So we can see that it is a signal input. But this is because, once again, everything is considered as a signal in Faust. We explained that in the quick start of Faust tutorial. And these 2 other inputs are the inputs for the left channel signal and the right channel signal. And here we have an output for the left channel and the right channel. Okay, so here we don't want to use it. We want to use the Faust to PD generated PureData patch. So we're just gonna call low cut. Okay, and here we have a nice graphical user interface with 2 sliders, exactly as we had before for noise. Okay. So now I will create an audio to digital converter here. Okay, and we have 2 outputs, and I'm gonna connect these outputs to the input of my low cut filter. And now I will create an audio digital to audio converter, and here we go. And I will connect the outputs of my effect here to that. Okay. All right, I save it. I will make sure once again that we're still connected to the jack router. Great. Okay. And now I will go to jack and see if PD is connected to Cubase 4, and if PD is still connected to the system, great, and I make sure that the right outputs are connected together. So this is fine, and now I will connect iTunes to PD. Okay. Great. And I won't connect my microphone to PD, but only to Cubase and the system. Great. Okay, so let's try it now. I'm gonna play one more time Gunnar's Faust here, and still with iTunes. So here you don't hear any sound, but this is because we're not computing audio with PureData. So now it is working. And now I'm gonna use the filter. Okay, so as you can see, this is working as well, and we don't have any problem. So our Faust object is working with PureData as well with Jack Qt. Okay, so the last thing we're going to show you in this tutorial is how to convert your Faust object into a mathematical documentation stored in a PDF file. Okay, so I'm going to close PureData, and I will go back to my terminal. So here we have still noisefaust.dsp and lowcut.dsp, and we've seen before that we have some specific elements in noisefaust.dsp that will create a nice documentation with LaTeX-like primitives here and here and here. Okay, so I'm gonna call a special tool that is also integrated in the Faust distribution, which is called Faust to Math Doc. Okay, and now I will just give the name of the .dsp file I want to convert into a mathematical documentation. Oh, sorry, yeah, I forgot the H. So now Faust is converting the .dsp file into a mathematical documentation. So now if I go back in my directory, I see that I have a noise Faust math documentation directory that has been created. And I have a PDF directory there, and in this PDF directory, I have a PDF file with the mathematical documentation of my Faust object. Okay, great. So in that case, the mathematical documentation is controlled by the different statements that we integrated in our file here that are mathematical documentation statements in our Faust code file. But we could also just compile this logcat filter into a mathematical documentation as well. And then we'll have a fully automated documentation of our Faust objects. So here I'm going to do Faust math doc, and I will just type lowcat.dsp. Okay, and as you can see, this is working as well. And now if we go back in our directory, we can see that here we have a logcat mathdoc directory, and we also have a PDF file. So if we open this PDF file, we can see that the automatic mathematical documentation of our logcat filter has been computed. Okay, great. So we hope that this tutorial has been helpful for you, and we recommend you to have a look at our website, which is faust.gram.fr. So see you later. Bye.